Good afternoon. I'm Bob Vavra, and welcome to Plant Engineering's webcast, Driving Safety, Electrical Safety in Your Plant. I'm happy to join you on behalf of Plant Engineering Magazine. Our speaker today is one of the top experts on the subject of electrical safety in the business, Hugh Hoagland, the technical consultant for arcware.com and easehazard.com. Hugh is one of the foremost trainers and researchers in electric arc protection. His NFPA 70E and OSHA 1910.269 training programs are used by many Fortune 500 companies and governmental agencies, including Alcoa, GM, Toyota, Bechtel, the Department of Energy, and hundreds of electrical utilities. Hugh has performed and developed testing by regional research and participation in the ATSM, NFPA, ANSI, CSA, and ISO standard groups for the electrical arc industry since 1994. He's performed more than 25,000 electrical arc tests on clothing, face shields, fall protection harnesses, personal protective gear, and rainwear. He holds multiple patents on devices protecting workers from electrical arc and has multiple inventions in the area, all owned by manufacturers. He's trained more than 80,000 people on the subject of arc hazards. He's got a BA from Kentucky Wesleyan College, so he's a former Cougar, and extensive graduate work at the University of Louisville, which makes him a former Cardinal. He's also a trained chemist and worked in safety at LG&E Energy for 5 years as a technical consultant. He's a former R&D director and technical manager in electric arc, and he's a consultant yearly on the issues of electrical arc and clothing. Tremendous resource for us to be able to tap into today. Hugh, good afternoon, and welcome to our webcast.
Thanks so much, Bob. We're going to talk about driving your plant, driving electrical safety at your plant, and I'm going to give you just some basic practical insights that we frequently see, kind of along the line of 10 mistakes we commonly see when people are trying to implement an electrical safety plan at their plant. And so we want you to understand how we can help, how learning about arc flash and how learning about electrical safety can help you implement a plan at your plant that will make things better. One delusion we see out there all the time, top 10 mistakes here. Number one, 100 cal delusion. Boy, I want to err on the side of safety. We see this a lot. We see companies go in, they try to buy extremely high-level PPE, they get somebody coming in that's selling PPE to do their training, and then they wind up scaring their workers or overprotecting. And one of the problems in arc flash about overprotecting is that, one, you make the workers hotter, which actually, we did a pretty big study on contamination in arc flash clothing for an Ontario Mining Association, our company did, and we found that actually sweaty, wet clothing is not as protective from an arc flash burn perspective as dry clothing. So you don't want to overprotect. You want to protect to the level of what you've calculated, but you don't want to overprotect. Overprotecting actually may decrease your protection than just putting them in exactly what they need to wear. So sometimes people think, erring on the side of safety is putting them in more protection. Actually, you may wind up going the opposite direction and not realize it. How bad is bad? Well, how much protection do you need to work in arc flash? This particular arc is actually going to, we don't have video here, but it's going to actually blow off a door. It's going to hit a worker in about 2 cycles. The worker in 6 cycles is going to be completely gone. The calculation on this particular kind of an arc is 6 calories. By overprotecting, you actually don't do any good at all because the worker's gone in about 2 cycles. What you really want to do in this kind of situation is train workers on where they should stand, which is not in front of the piece of equipment in this particular case. Standing to the side of this piece of equipment, we call it the left-hand rule or the one-hand rule, actually is more protective than wearing PPE. If you stand to the side, your chance of being burned is extremely low because most of the electromagnetic forces force the energy directly out the door, and you're going to be much better protected by putting yourself in the right place than you would be by trying just to wear the PPE. So if you look here, that's 1 cycle into the arc, which is a 60th of a second. The door is halfway to the worker's face, and then in 6 cycles, the worker's completely gone. His body's actually leaning back away from the door, and we had cotton T-shirts on, several different ones of these tests, and we never even ignited the cotton T-shirt because the door basically hit the worker in the face and took him out of the way before the energy could really hit him. Standing to the side, you see the hot gas of Fireball. Yeah, some of that's going to hit you, mainly on your arm and your hand. We actually have some companies that go in and wear cut-resistant sleeves that are also arc-rated. They wear a leather glove or a cut-resistant arc-rated glove, and they operate these types of equipment just from the side, and they can wear a cotton T-shirt. So it works quite well by making sure you're wearing exactly the right PPE and not over-PPEing it. This is really important, and it saves you a lot of trouble. Another type of arc that people don't think about is a tracking arc, and we wrote a paper on this. This is part of the video here that came from the electrical safety workshop, and we found that we could actually ignite a T-shirt underneath an arc-rated shirt with an electrical contact of 15 kV. So if you're in higher voltages, electrical contact actually can ignite clothing underneath. And you'll see here, that was 2 cycles. That material was, the arc was actually underneath the clothing for 2 cycles, a 30th of a second. The calculation from Arc Flash here was only 1 calorie, which you'd never think would be enough to ignite the garment, but it was. And the key is training on a full-blown electrical safety and not just throwing Arc Flash PPE at workers is the critical thing. Here, making sure people understand that what you wear underneath is important. In this case, if somebody was wearing melting materials, it would have been much worse. They wore cotton materials, which ignited. If they were wearing an arc-rated T-shirt, they would have been much better off. And we especially recommend that in high voltage. Lower voltages, it's much less likely to happen. Here you can see the arc from a different camera angle is actually coming down the power line, and it's outside of the clothing in about a 30th of a second. So don't overkill on a PPE. It sounds smart, but it has 2 negatives. One, it sends the wrong message. You scare workers on things that actually may never happen to them, and something that's very unlikely to happen. Number 2, if the workers don't believe it, then they'll cut corners when nobody's watching, and then watch out for salesmen's little lies. Better safe than sorry, better safe than right. It's really better to be knowledgeable and making the right decisions. So think about that when you're making your Arc Flash C. And then this is a real common thing we see out in the industry. People go to a free seminar, they pop in, and it's mainly run by clothing people. And I've got a lot of friends that are clothing people, and most of them are good people and trying to do the right thing. But the further it gets away from the manufacturers, the more people talk about, well, we got kits, or we got programs, or we have a coverall program. The problem with not matching it correctly to the hazard or having a kit is, without training, people cannot have on the kit. I have a lawsuit that happened in Boston, Massachusetts. Guy was in a large building checking a motor control center. They were opening up, doing infrared testing. They were opening the cabinets. They really never read 70E. They went to a 4-hour training with a company that was primarily set up to help sell clothing. They were a training company. They were trying to get people to do full-blown Arc Flash studies, but they gave kind of a cut-down version of the training, and this guy didn't get it. He didn't understand. He didn't get a copy of 70E. They went over just a few scenarios, mostly scary scenarios. He didn't think this was one of those scary scenarios, so he didn't wear the kit. He had a 40-cal kit. He got probably 15 cals, but it ignited his shirt, burned it off of him. His supervisor threw a rubber blanket on him, a rubber blanket that also caught on fire. They had that nearby. He did finally put him out, but he had a rubber blanket and clothing ignition. He died. The supervisor caught on fire, was able to put his out, got some burns, but it's one of those things where they had the right PPE. They probably had a little too much overkill, but they had the right PPE, but they had no idea when to wear it. Electricians don't intuitively know when to wear the gear. They've been doing this for 40, 50 years. You need to have a good, thorough training program, and you need to have a written electrical safety program, according to OSHA, so that people understand when they wear what. This company, in essence, is going to wind up being out quite a bit of money over a death and over another burn because they didn't really thoroughly understand their program. Making the program cheaper and easier, that's what you think may happen when you have a kit. I'm not anti-kits. Make sure the kits actually match what you have. I'm a much better friend, or a much better, much bigger fan of having a 40-cal kit and a basic arc-rated uniform. That's a much easier program to roll out, and just having kits and not knowing when to use them is a problem, and then also there's lots of other ways. Had a lady, I've just changed her name to Darlene. She was actually she had a level 2 kit in her truck. She had worn it several times during the day. She was out grounding some switchgear, and the switchgear was operated by remote, so she couldn't actually operate the switchgear from there. But she went out, and she was just picking up the grounds and getting ready to close the door. And so she according to her company's policy, wasn't required to wear arc-rated gear during that particular operation. She was required it when she opened the door. She was required it when she was actually working on it, but this equipment was de-energized and grounded. But someone turned it on by distance right after she had taken off the grounds, and they were supposed to be waiting for about an hour, but somebody accidentally hit the switch too early, and what wound up happening was an arc flash. The piece of equipment failed, no fault of hers, but in this situation, we determined that if she'd been wearing the coverall program, the actual PPE, she would have been better off, but she still would have been burned because, one, they had never really done a full hazard assessment, and two, by letting them wear the coverall sometime and not wear it at other times, she wound up not having it on when she needed it. If this company had been in a full uniform, that they just went out in the right gear for the basic level of flame resistance and arc-rated low-level gear all day long and then put on a coverall, different things, and then put on a flash suit when they needed, this person would have been much better protected and she wouldn't have gotten burned hardly at all, if not any at all. Another problem we see is people go out and they say, okay, let's get a Class 2 size 12 rubber glove for all of our arc and electrical exposures. And what happens in this kind of situation, these kind of programs, they just try to do a worst-case scenario program. We went out to a plant not too long ago. We'd done electrical safety training at the plant. We did an audit about a week after the electrical safety training and found that people still weren't using their arc flash or their electrical safety gear. They had never used it before. They had an incident. They got cited by OSHA. They decided to implement a training program. Well, we offered them a free audit because they were local here and I wanted to train a new auditor. And when we went out and did the audit, we found out they still weren't wearing the gear. There were two reasons. One was they came in and said, okay, we can't spend this much money on this stuff. We're going to buy one kit. It's going to be locked up at the manager's office. So the night shift actually didn't have access to it. Second thing it is, because those are expensive, those kits, is what the guy said. The second thing that happened was they said, okay, what's the maximum voltage we could work on? And someone said, well, we got 4160, which they actually never worked on. He said, okay, great. Let's go the next notch up, which will be a Class 2 glove, 17,000-volt glove, and then first time anybody tried to land a control wire in that 17,000-volt glove, it was impossible. So basically the workers, because nobody was auditing, nobody was checking, they didn't wear it. And then the second thing was they had a flash suit. It was a 100-cal flash suit because they bought the biggest, best kit. That's what they assumed. In doing that, they actually wound up leaving the workers less protected because they didn't really think this through. Everybody needs a pair of rubber insulating gloves if they're going to do voltage testing. They need to have it for the voltage, close to the voltage that's required. Don't go too many classes above what you're actually doing. And if you're doing high voltage and low voltage, you really need two sets of gloves to make sure you can actually handle the small parts and still be able to do the big work too. Now, this is another problem we find is people don't get the right kind of suits. We've also found problems where people buy one set of suits, and you got a guy who's 5'4", and you got a guy who's 6'9". This literally happened in one of our classes. The guy standing next to a guy, one guy's 5'2", the other guy's 6'9". They both have to wear the same flash suit. So make sure you get flash suits that fit at least a broad range of your people, and they're reasonable. Trying to buy it for the 6'9" guy means the 5'2" guy's got to roll the sleeves up or roll the legs up, and it's not realistic for them to wear. And thinking about your workers that have smaller sizes or larger sizes. Okay, flame-resistant labeled clothing is all I need for electric arc. This is another delusion. Flame resistance actually doesn't have a real strong definition. The definition is that it goes out after you take away the ignition source. But that's actually not true in electric arc. You need something that's actually arc rated. This is really important. We see a lot of things in the market, especially specialty garments like hoods and things like that actually aren't arc rated. They don't have the right labeling. And they say they're flame resistant. Well, what they mean is that we've done a vertical flame test and it went out at whatever length we've set. Some people say 4 inches, some people say 6 inches. Actually, this vertical flame test is a great control device. It's a great control standard, but it doesn't mean that something will actually work in your hazard, in this case, electric arc. You really need to make sure you're matching it to the hazard, and matching it to the hazard means getting arc-rated gear that has the right arc rating for the exposure you have. In clothing, you want to meet ASTM at 1506. You don't want the D6413, or there's an old federal test method that people use, or they use NFPA 701, which is actually a curtain standard. These are deceptive companies in some cases, or they're companies that are just not very knowledgeable about FR. They're frequently imported. As a matter of fact, in almost every case, they're imported. There's good imported stuff. there's bad imported stuff. Always check the labels and make sure something meets the standard. If you have any question, if it's half the price of everybody else, there's probably a problem. In some cases, it's actually deceptive and they're really not selling you what they say they're selling you, and we've seen this a few times. Another thing we see in these FR is some of them say they're flame resistant until washed or dry cleaned. Well, this is not flame resistant. I didn't wash it. I didn't dry clean it. But when you look at the next slide, you'll see that actually this wind guard melted onto the worker's head. This is a company that I contacted. We did some testing for them. They were telling people that we had tested it. They didn't point out, though, that we had told them it failed and that it wasn't acceptable. And so they were using my name. I called the person. He said, well, you know, I'll got insurance, and I'll come back under a new name if we get taken out of business. Obviously didn't care about safety. Be very careful about companies that don't know what they're talking about. This was advertised in major magazines, and every time I see it advertised, I actually call the company and say they don't meet the standard and make sure that they get something that does meet the standard. They can make things that meet the standard. It's a key is just doing it. This is a flame-resistant, quote-unquote, on the right, rainwear material that actually just melts onto the workers. Don't trust anything that says it's flame-resistant. It might work okay if you're exposed to a big lighter, but it's not going to work well in flash fire. It's not going to work well in electric arc. You want something that's flash fire rated if it's going to be for flash fire. You want something that's arc rated if it's going to be for arc. And then, of course, firefighter ratings and wildland firefighter ratings if you're in other situations. We bought this PowerPoint program. We've got lots of people that buy a PowerPoint, slap it up, fairly inexpensive way to start your training program, and not always bad, but you really have to have thorough knowledge. You have to understand the program. And just training, even if it's great training, is not enough. Generic training doesn't always get at the finer points and make sure people really understand things. You need site-specific written programs. That's required by OSHA. Unique hazards have to be considered. FR cotton and 20% body burns from sodium hypochlorite. We had a company that didn't really think about the other hazards. Aramids don't do well with welding spatters, especially large amounts or molten metal. Melting polyester in clean rooms is very common. You need something that doesn't melt and something that's actually arc rated, but still you have to meet those clean room requirements. So think about those unique hazards that you have in your workplace, and if you need help, get help from a consulting company or somebody that can actually help you. A lot of times the clothing manufacturers will have lots of help for you on this situation, and a lot of the laundries do too. So just or your flame-resistant clothing sales people can usually help you. Be careful about distributors. Some of them are really knowledgeable. Some of them are not quite so knowledgeable. So making sure you get the technical support that you need in something that's related to arc flash, and especially if it's related to arc flash and also other chemicals, things like that. And then another thing people really need to do, and we see a lot of people don't do it, as a matter of fact, the majority, you need to train, you need to audit, and you need to have knowledgeable management. That will give you a great program. We find a lot of companies do training and actually have some really good training companies come in. There's several of our competitors that do a great job. They have a good training class, and the trainer's very knowledgeable, but it's never audited. Nobody knows if it's actually happening. And when we go in after our trainings or after other people's trainings, we find in audits that a lot of people are not doing things. And it's probably a lot of times because they don't understand, sometimes because there's not a management commitment, and sometimes it's because they don't have the right PPE or the right knowledge in place to be able to actually follow the standard correctly. And then another program mistake is, I'm going to buy everybody an arc flash suit and we can do the calculations later. Well, the problem with this is don't put off your PPE purchase. Assessment usually won't change the maximum levels, and it won't change the main levels, but you want to make sure that you actually do that study over the long haul and get it right. Just buying a flash suit and putting everybody in it. I've seen companies that actually put people in flash suits for measuring 120-volt wiring. That's ridiculous. You don't need to be in a flash suit for that. Assess the hazard at least to start. I recommend companies start with the label version. If you don't have all the information on the labels, at least start with the tables and start the program there. Call it preliminary, start it out, put people in table required PPE, and then when you get the funding, when you get the time, get that upgraded to a full-blown arc flash gear. Now, I'll be criticized for this, and that's okay. We've done a study of 40 different incidents, and I've done over 150 incident investigations, and I found only 2, and they were both in electric utilities, where following the 70E tables would have gotten anybody killed. And in both cases, it's because they weren't working on something that blew up in a manhole. So if you're not in manholes, the chance of you actually dying from following the 70E tables, I would say, is very, very close to 0. So it's really important to follow the tables completely and understand them, but it's also important to go ahead that next step when you can to get the assessment done. But if you're a contractor and you don't own the property, it's quite difficult to do anything other than follow the tables. You might not bump it up a notch. You might look at your systems and also look at your experience and do a better job, but the tables may be all you can do. Do something. Don't just ignore this. Operators often work in natural fibers, but their gear may not be rated depending on the level of exposure. So you want to make sure that operators have training on where to stand when they're operating equipment and then put them in the right PPE for that exact job. And it may be something as simple as, and I've said it 1,000 times, I love this idea because we've seen it work so well for so many companies. Instead of making them wear long sleeve cotton shirts, you put them in that welding sleeve that's arc rated, and you put them in an arc rated glove when they operate disconnects, say 480 volt disconnects. Something that can give them a burn. It's better just to put them in a small amount of PPE than trying to go overboard or trying to force everybody to wear a long sleeve shirt all day long when they're only exposed maybe once or twice a day operating a disconnect or operating some kind of an electrical device. Make sure they match the hazard, but make sure you don't overcompensate. Number 7, focusing on arc flash rather than shock. I do almost all the arc flash testing in the world. We do over 95% of it. We do about 8,000 or 9,000 arc flashes every single year. I've been testing now for 18 years. Our little bio there is not quite updated. But I can tell you in accident investigations and in real life, more people die from shock by far than die from arc flash. So there's often an arc flash associated with shocks above 480 volts, but the arc flash may not be what kills people. So don't focus only on arc flash. Focus on shock. Get the shock training. Many of your clothing companies that do testing, that do training, don't really understand the shock side, and getting that shock side training in there is really critical. Make sure you understand the most important thing. Shock's the #1 killer from electrical hazards. You get more bang for the buck with the right PPE than with engineering. Getting the right PPE in place means your people probably won't die. I'm all for engineering, but engineering should be done primarily to increase the reliability of the plant and decrease the risk of arc flash, and it might even decrease the energy in an arc flash, but it probably won't get you out of PPE. Our world today, just very few people, maybe operators, can get out of PPE with a properly engineered system, but electricians are almost always going to have PPE until something dramatically changes. So not saying, oh, well, I'm just going to wait and we'll get out of the PPE once we get our engineering study done, really won't work for you in the long run. So do the PPE piece right, do the training right, and then work on the engineering. Not against engineering. It's a wonderful way to get things out, but you've got to get everything in place so you don't kill somebody waiting for the engineering study. I've seen that happen actually 3 times. People put off the PPE, were doing an arc flash study in 2 cases, and actually had somebody really badly burned because they were not using the right PPE for the arc flash study, which is pretty horrible. Okay, ignoring specialty gear. A lot of people don't think about all the different things they have to wear that are exposed to arc flash that are not really directly related to arc flash. Hair nets and beard nets, clean room gear, gloves. There is now an actual arc flash standard for gloves. Disposable FR wear is something that's out there. Rainwear, chemical gear, and chemical standard gear, making sure you're getting the right things if you have chemical exposures and radiation exposures in some industries' cases. Shoes, making sure you're wearing the right shoes. Other specialty PPE needs to be evaluated by your AHJ. Maybe you've got a SCBA that's worn periodically. I recommend for arc flash, get a firefighter's type SCBA if it could be exposed to an arc flash. So thinking this thing through can actually save you headache in the long run when you've not thought through the specialty equipment for those arc flash jobs that also have other hazards. Number 9, the safety department can do it on our own. There's a little safety myopia. A lot of people in safety, they understand don't daisy chain the extension cords together, but they really don't understand electrical safety. I found many competent safety people that really get it about electrical safety, but they really need help. One of the largest companies that has tons and tons of chemical and electrical, DuPont, did a study, and they found that actually 80% of their injuries over 30 years were because of arc flash ignition of clothing or arc flash itself. Even though they had a strong safety program, at one point, 10, 15 years ago, their safety department didn't run the electrical and the arc flash program. didn't have the expertise. That was done in engineering. And they found that their fatalities would go up and down and up and down, and they found out it actually overlaid a few years after the engineering's budget was cut, because safety training would get cut. So they went back in and said, we're not cutting electrical safety training. So they took that line item out, put it under safety so it didn't get cut. DuPont's very committed to safety, and they made sure that their people always got the right training. They got their electrical safety audits done just like the regular safety audits, making sure you have that expertise either in your safety team or using someone from outside the safety team to do your audits. And in DuPont, they do external audits about every 3 years to check over those processes and make sure they're still working. They also use ANSY's E10, so they have a continuous improvement for improving their safety processes. These are critical things to do, and they'll really make a big difference in your industry and making sure that your plant actually complies with the standards and, in complying, doesn't get anybody hurt or killed. 5 people you need to do a proper arc flash assessment. This is something I made up a few years ago, and it's actually worked out quite good. You want a troublemaking electrician. You want the nicest electrician, you want the smartest electrician, you want an electrical engineer, and you want a safety person. All 5 of those are needed. The troublemaking electrician will raise every question you could possibly ever think of. The nice guy can help keep him calm down or her calm down, and the smartest electrician and the electrical engineer will figure out a way to engineer out some of the hazards and maybe change the work processes so the people are more safe, and the safety person can document, follow up, audit, and make sure this stuff happens. So you need a team to do an electrical safety assessment and making sure you have a good electrical safety program. This is just something we've seen so many times, that people focus on just the simple things and don't really understand all the things we need to look for. There's actually a requirement in NFPA 70E and in OSHA 1910-269 for utilities and utility-type electrical exposures that requires an annual supervisory work practice inspection. This should be a documented inspection where you actually watch and make sure workers know how to work properly. This really needs to be done by an electrically competent person or somebody who's competent in 70E and the OSHA standards around electrical safety. This demonstrates and helps document that your people actually have task proficiency. It identifies retraining needs, and it's supervisory level, so it hits those people where they actually work and makes sure you're actually following through on these people. Another great thing about this is it actually helps you evaluate your qualified persons and make sure they really are qualified. We find a real disparity among people at companies. There's some companies the people are fantastic, other companies the people really struggle. So it's really important to make sure your people are really qualified. Just because somebody said they were a maintenance electrician at another plant doesn't mean they can really do it safely in your plant, and this supervisory annual inspection helps to actually weed out those folks or get them the retraining that they need. Also, it helps you catch things that might be wrong. Annual field work audit. We also recommend that you have a overall company separate audit where you go in, and here's the best practice on this is year 1, let it be done internally by your local safety or electrical department. Year number 2, cross-pollinate. Take some professional from another plant or another industry and have them come off, and you go over and do their audit. And then year 3, have an outside audit company come in and actually work and give you a real full-blown audit from their perspective. What will happen when you do this is you'll actually get new things about every 3 years, but you will make sure your program is continuously improving. A better practice, and that's the best practice, a better practice is to at least go in and do an audit and try to find out what these things are from your above your supervisory audit. Do this as a general audit across the board. We went and found a study on the effects of training and goal setting and knowledge of results on safety behavior. In this industry, what they did was they went in and they looked at a baseline of back safety, hard hat safety, and safety glasses. And they found that the baseline here was that if they just gave people PPE, they actually watched on a hidden camera people working in a warehouse environment, and they found that if they just gave people the PPE, 65% of the people followed the rules. They would wear the PPE when they were supposed to. There was no real training. There was no auditing. There was nothing except just, here's the PPE. You know what this does? Okay, great. Go to work. When they came in and they did some training on back safety and did some training on hard hats, safety glasses, and why they should be worn, their compliance went up to about 72%. A little less than I expected when I first read this study. Second thing that happened was they came in and they said, we're going to be auditing in a week or so, and people would stand around with clipboards and act like they were auditing. They were still watching through the cameras and found that when the auditor walked away, still only 78% were following the rules. But when they came back and they reported to the workers that, hey, we went in, we've been watching on secret cameras, and we found that 95 or 80, only 80% of you guys are really doing it right. They found that after that, the actual improvement went up to 95%. 95% of the people were following the rules. Now, that doesn't mean that you'll never get anybody hurt. But what it means is, and they said, we're not writing anybody up. This is not about trying to fire people. This is about keeping you safe and caring about you. They interviewed some of the people after the fact and asked them, why did your behavior change? Why did behavior in the plant change after this audit and after reporting these results? And they said, well, we've realized that these people weren't out to get us. They could have fired numerous people if that's what they were out for. They were actually out to keep us safe. And that meant a lot to us, and we decided that, they convinced us that these things should be done, and we decided to do them. So it's kind of funny how that might work in being not retributable, but making sure that you're getting your people to understand why you're doing the safety things. Electrical safety hazard assessment audit should happen, your electrical safety audit should happen no more than every 3 years. This is your documents. You actually audit the documents. You want to look at your written program. Why every 3 years? Because that's as often as 70E comes out. If I was in a utility setting, I would do at least every 5 years, and then any time the OSHA standards change. We actually have a new upcoming OSHA standard for 1910-269 for utilities. It could literally come out any day. It's been proposed since 2005. It's finished with the OMB process, and my understanding is that it could come out from OSHA just whenever they can get it on the website. I'm sure this is kind of a slow time of year. It may not come out till after the first of the year, but it could be any day now. I checked this morning. It's not out yet, but this could change things, especially for electric utilities, and I think most are aware of that, and if you're not, let me know. I'll be glad to send you a presentation on that. First, review your ARC hazard assessment a minimum of every 5 years, or anytime you've made major modifications or renovations that could change your arc flash energy levels. Changing breakers, changing fuses, changing settings on breakers could actually change your arc flash energy quite dramatically. So make sure you're actually auditing that periodically and keeping up when you make changes in your plant. Some plants, they're changing this stuff all the time. You want to have somebody in-house doing this so it keeps up to date all the time. We have a DVD and a presentation that I do on 7 electrical safety habits, and I found that the first 3 of these habits actually prevented about 98% of all the arc flash injuries that I've seen in the field. And habit 1 was always verify the absence of voltage and use voltage-rated gloves and tools. The number 1 killer is shock, and if you use verification of the absence of voltage with a proper meter and checking the meter and checking the voltage, using the voltage-rated gloves when they're required, and using insulated tools, you'll find that most of the fatalities will go away. The second thing is understanding and using arc flash and shock boundaries. This means that you don't have a supervisor standing right over top of you while you're working on a 13/8 switchgear talking about the weather or something. They need to be in the right PPE, or they need to be outside of that arc flash and shock boundary. The third thing is wearing arc-rated daily wear and a face shield. It's not required that you wear arc-rated daily wear. It's required that you wear arc flash gear when you're doing the work. But I find that if people just have, especially the electricians and electrical maintenance people, have on a base rating of 4 to 8 calories and then wear a face shield when they're doing any electrical work, that most of the injuries and most of the fatalities are gone. And then add the other 3 habits, and you'll have a fantastic program that actually can improve and get better all the time. And now, number 10, fill in the blank. What are your mistakes? What are things that you've heard about that worked or didn't work? And we're going to take some time to answer those questions because I see they're kind of pouring in. This is our email address here. If you want to sign up for our Electric Arc newsletter, it's free. We have the DVDs. They're not free. They're charged for those. You can email us, or you can drop us a quick line or drop us a quick call, and we'd be glad to get you some information about that. The newsletter, the Arc News, is actually free. It comes out once a month and gives you new information. I'm going to slide here to our next one, is submitting questions here and getting anything else done. So thanks a lot, and I'm available for questions.
Hugh, thanks so much. Great presentation, and we'll get to as many of the questions we've got from the audience as we have time for. If you've got a question for Hugh, just type the question into an Ask a Question box on the webcast console and hit send, and we'll get to as many of those as we can today. We also invite you to take a moment to answer a few questions from our exit survey that will pop up on your screen at the end of the webcast. We use these answers to help us make improvements to our ongoing Plant Engineering webcast series. And once again, for those of you who joined us late, you'll be able to access the archived version of today's presentation at www.plantengineering.com in about 7 days. We'll let you know that via email. We'll send an email to all registered attendees with a link that will take you right to the page that has the archived version of today's presentation. It's a great opportunity for you to review this great content with others in your organization. And what we've also seen is that people on different shifts will be able to access this information on demand and be able to review this important safety information with others in their organization. So we encourage you to do that. And we want to get to the Q&A portion now. And before we get to some of the specific questions from the audience, Hugh, I want to go over a couple of things that you talked about and a couple of things that we wanted to take a look at in today's presentation. We talked about safety and electrical safety, and that's a paramount issue for us, for you, and for everybody in manufacturing. But let's talk about the relationship between electrical safety and electrical efficiency for a moment. We look at electrical systems on the safety standpoint just in a way to preserve a safe environment, but it also has an impact on efficiency in the long term. Wouldn't you agree?
Oh, absolutely, Bob. You know, we have a really interesting story. We had a plant that we were working on doing an arc flash study. And this plant, there was actually a guy in the plant, and it's one of my late engineers who's one of the founding engineers of eHazard. His name was Don, and Don had a guy, and his name was Muldoon. And Muldoon was, oh man, he was so upset over this arc flash study. Why are we wasting all this money, all this time on doing this arc flash study? Well, we've never had anybody hurt with an arc flash at this plant, and he was quite upset about this. And Don went back in they worked about a year and a half on this program and upgrading fusing, upgrading switch gear in a couple of cases, but mostly just changing fusing and breaker settings, and got this plant where it was humming and everything was very reliable, and it also had reduced the arc flash energy. In one case, by putting on a maintenance switch, they had reduced arc flash energy from 80 calories down to 8 calories when the worker would be working. They just flipped the maintenance switch in, it would kick the breaker into instantaneous, and they could work in a lot less gear. And so the workers realized some value in that, but they were having to wear this new clothing. They were griping about this. And he came in to do training, and Muldoon was sitting in the back of the room, and this guy said something about this was silly and crazy. And Muldoon jabbed him real quick. He says, "You shut up and listen to him. He knows what he's talking about." So Don went back and asked the guy, he said, what's going on, Doon? You've really changed your attitude here about this arc flash study. He said, "Well, Don," he said, "you remember 5 years ago, not too long before we started this arc flash, we had a transformer blow up and shut down the plant for 5 days, cost the company about $1.5 million. He said, "Well, you know, I thought that this had nothing to do with arc flash and that reliability and blowing up a plant or any of these type of things really mattered. I thought, you know, it would just blow up or not blow up." And he says, "I began to realize we had a fault in the transformer that was the sister." Basically, this plant was set up on two legs. They were exactly the same, one coming in from one end, one coming in from the other end. And he says the other transformer failed, and we think maybe that's exactly what had happened in the old transformer. But instead of 5 days, in 5 hours, because of this arc flash and protection and proper coordination, we actually were back up and running the plant and didn't put people out of work and didn't have to shut the plant down for a long period of time." And he says, "You know what? And if anybody been by that other transformer, they would have been dead. And in this case, we were standing there nearby, and it just basically poofed real quickly, and we went in, we cleaned it up, we figured out what the fault was, we fixed this situation, went back, put the fusing in, and in about 5 hours, we were up and running again." So when you think about that this long-term will, of course, change your safety program if you do the proper engineering, and it might make somebody safer, but that's actually a long shot. 1 in a million will get killed from arc flash. But when you start looking at reliability, if I can keep my plant from being shut down for 5 days, or if somebody gets killed, OSHA may shut down your plant for 5 days. That productivity kind of goes hand in hand. Good preventative maintenance and good proper device coordination will make your plant more reliable, and the after effect is that it actually makes it safer from an arc flash perspective.
And that's one of these things is we can't look at any of these issues around electrical management within the facility as single issue items. They're all interrelated and all very, very important to the overall safety, health, and profitability of the facility, and those are all things that plant engineering readers care a great deal about. Let's also talk for a second about the issue of PPE versus safety training. You talked a great deal in the presentation about this, and I wanted to go over that once more because we tend to look again at these issues as singular, and yet they are absolutely interrelated.
Yeah, what question specifically?
Well, specifically, let's talk a little bit about safety training as one aspect of an overall electrical safety program. PPE is another. Sometimes, as you said, you just buy PPE and that's your safety program, and it's so much more detailed than that.
Yeah, it really is, and I think that near the end there, when I start talking about tying in training, proper PPE, and an audit, all three of those really work well together. And what happens is you find out, you get out in the field and you bought some PPE that may be a little bit cheaper, and you find out people aren't wearing it because they're getting skin rash issues or whatever else is going on, or people sometimes have fear. I actually get questions pretty regularly about people who have fear of a specific material. Some of the fabric manufacturers will get out and scare people about their competitors' materials, that they contain this, that, or the other. And the reality is, if you use good quality materials, most of the materials, if not every single material sold in the U.S., is very safe for workers to wear, and make sure you understand the program from the ground up. So asking those questions, answering those issues, getting out in the field and making sure it's working, and then doing training. We find a lot of companies come in and they'll have us do training and they haven't got the PPE in place, and then the workers lose some credibility for the company. Why would you do all this training and tell us that we could die tomorrow if you're not going to get us the PPE? And so you got a kind of chicken and egg thing taking off there, and then you also got the chicken and egg thing of the engineering. If you have a good quality training company that understands that putting the PPE in place, getting the workers to wear it, and getting comfortable PPE. Bob, when I started this back in 1994, I was one of the first people to ever arc test. There was a few people who predated me, fantastic people. I stand on the shoulders of giants. But when we started, there were 4 fabrics that were arc rated. Last month, we tested 60 fabrics last month. So the increase in the quality, the increase in the comfort, the increase in even the protection level has really gone up. So making sure you put that 3-leg stool in place, proper PPE, good quality training, and engineering and auditing, those really will make a big difference in the long term.
And we've seen over the last several years as we've been doing this kind of webcast, as well as our long-time Arc Flash University webcast series, which we'll do again in 2014, the awareness on this issue has gone way, way up, and yet the interest level is still tremendously high in understanding both the new standards as well as the new equipment that's out there in the market to address this issue.
Great.
Yeah. We'll get to some of the questions now, and this ties right into everything we're just talking. One of the questions from our audience: how do you know when it's time to replace PPE?
Well, that's a good question. It depends on what PPE you're talking about. Hard hats, electrical hard hats, should be replaced every 5 years, and the suspension should be replaced every 2 years, unless the manufacturer has like an expiration date. And some do. They kind of recommend about 2 years. But you can also test them with a squeeze test that you squeeze in the hard hat about 1 foot or about 1 inch on each side, and then if it snaps, crackles, or pops, you throw it away. So there's different things for different pieces of PPE. Of course, shock PPE, like voltage-rated gloves, should be replaced anytime it fails a shock test or anytime you have tackiness, several things like that. For arc flash PPE, which is probably what this reader was talking about, for arc flash PPE, you want to make sure you replace it when it has a major issue. And this is really difficult. I say that if you get something that's extremely faded, in other words, and we had this actually happen in Canada, we had a laundry company that didn't have a lot of experience with flame-resistant clothing. They took a high-quality flame-resistant treated cotton. They accidentally, instead of putting in 3% chlorine of peroxide bleach, they put in 30%, which they shouldn't have used any bleach, and it actually destroyed the FR. the company called me and said, hey, we think the FR may be bad in this. I said, well, why do you think that? And he said, well, when the guys pull on the arms tear off. And the shirts used to be navy last week, and when they came back, they were pink. And I said, yeah, that's a really good sign. We did have the fabric manufacturer test the garments, prove that they were not flame resistant anymore, and that's an extremely rare condition, but it can happen. So if something starts to fade a lot, talk with your uniform supplier if you're renting. Most of them have processes in place, and actually any of the big ones do, to get rid of garments as they show signs of wear. I've never seen a garment that was not extreme that did not maintain its flame resistance for the life of the garment, anything that was sold by any of the big laundry companies in the U.S. And I've never seen home laundering destroy the flame resistance of any garment. So if you want to look at it from that perspective, you get big holes in it that are not repairable, or you get other situations where you see an extreme fading, or if there's any chance and you just think there's a problem, we actually offer, through our testing company, we actually offer garment evaluations, and you pull 5 garments and you send them off, or 3 or 4, and we actually do an evaluation to make sure the garments are still flame resistant. We can do that with very small scale tests. You don't have to do an arc test to see if they're still working correctly, as long as it's a material that we're very familiar with. So there are ways to do that. We just recommend that you watch them, make sure they're not extremely faded or there's not big holes in them, and usually they're fine.
And this ties into the next question, which is just discuss the differences between arc flash rated clothing and the flame retardant clothing.
That's great. All arc flash rated clothing is flame resistant. Flame retardant normally is something that's treated to become flame resistant, and there's no huge differences between those. Inherently flame resistant materials, you can't wash out the flame resistance, but there are other ways you could compromise them by hydrocarbon loading, or by washing them in extremely hard water like salt water or something that can actually hurt the nitrogen base in some of those. Others don't use a nitrogen base. You can't hurt them no matter what. But most materials that are arc rated are flame retardant or flame resistant. All materials. So the term flame retardants, though, doesn't really mean anything. And so again, as I said in the presentation, and we go into a little bit more in our training, we want to make sure that you understand you only get arc-rated clothing for arc flash exposures. And if you have flash fire and arc flash exposures, get something that is flash fire and arc flash rated, and you'll be in good shape. Just stay away from something that's generically claiming to be flame resistant. They often don't use the right standards, or in a few cases I've found companies that are actually just outright deceptive. It's very rare, but it has happened.
Sure. And the only question that we get more than this one is, how can I avoid wearing a lot of PPE? We get this one quite a bit. How do you get your upper management and your ownership on board for mandated arc flash analysis and training? Well,
it'd be great if it was law. And for utilities, it will be law within a month, but it could be 2, 3, 4. It's actually slated to be on the OSHA agenda. It was slated on the OSHA agenda for March of this year. It still hasn't come out, but it was just an OMB issue of the economic studies, and that now I understand is completed. So it will be law for your G, T, and D. So transmission, distribution, and generation of electricity will be required by law to do arc flash analysis and arc flash assessments. Anybody else is under an NFPA 70E, which is not law, but it is a reasonable assessment. And I actually did a webinar yesterday, and we went into an actual arc flash analysis citation that OSHA did in 2007, $7,500 fines, and they basically said, here, you didn't do this, you didn't do this, you didn't do this. They used the general duty clause of pointing out these issues, and then they also used 70E as the abatement. And they were successful. This company actually went in and did an arc flash study, and so this can be very successful if you think about it that way. But I try to sell management on the idea that, your electrical workers are some of the most valuable workers you have. They're the hardest ones to replace. You can get somebody to throw a switch any day. It's tough to get somebody who has electrical knowledge. We had a plant that had an electrical accident that got rid of the maintenance manager and 2 electricians, and they only had 3 electricians. Now, you don't think that affected that plant. We know it affected that plant. So if you're just thinking about dollars, these things cost millions of dollars. You may or may not be insured enough to cover this, but even if you are, your workers' comp is going straight through the roof. Why don't you think about this? We try to get across this. 300,000 at-risk behaviors leads to one fatality. But in electrical, it's 10,000 at-risk behaviors, according to the statistics. So it doesn't take much electrical mistakes to get somebody killed. You can do hard hats and safety glasses wrong and do right and do electrical safety wrong, and you're much more likely to have a fatality by not doing the electrical safety right.
I get enough press releases from OSHA across my desk to be able to tell you that the cost of OSHA fines and mandates, not to mention the potential for some egregious cases of criminal behavior in terms of turning a blind eye to safety altogether, the cost of those is many multiples higher than putting in a good, solid electrical safety program for any manufacturer in this country. So the reason we do these webcasts is to try and drive those points home as completely as we possibly can. And I think we can't seem to be repeating it too much because the press releases keep coming across my desk. Let's go to another area. How effective are arc flash relays in lowering arc flash hazards and PPE requirements?
They can be extremely effective. The only thing about arc flash relays, some of them will crowbar the equipment, so you have to make sure that equipment downstream can actually be shut down without causing safety. You can't put arc flash relays and some of these other technologies in if shutting it down would actually cause the nuclear power plant to overheat. But they're extremely effective, either arc flash relays, current limiting fuses. Each of these technologies have their place. We always encourage people be careful about having the company that only sells one selling you the one that works for them, because it might be the most expensive thing. We find in some cases current limiting fuses is much cheaper to operate. In some cases, putting in an arc flash relay is much more reliable and can lower those energies just as effectively and have very little cost long term. It depends on the process, and you want to make sure you've gotten with a qualified engineering firm that can actually help you. Our company doesn't do design and build, but we do consulting, and we encourage people to use these relays, current limiting fuses, and other technologies to make sure they protect their workers without having to go to PPE or going with less PPE.
We've got time for a couple more, and those that we don't get to here during the live webcast today, we will try to make sure that answers are provided offline. But we, as always, we get a lot of questions on these topics. One other question: is there a standard form to use for the supervisory annual inspection?
There's really not. We actually have a free service. If you go to inspectionpad.com, there's an iPad app, and I think it's going to be Android available soon. We don't have any money involved in this. We don't make any money off this, but we did provide a 7 electrical safety habits audit that's based around our 7 electrical safety habits. We have about 40 questions on there that we developed as a supervisory level audit. If you use the Inspection Pad iPad app, it's free. You have to log in to be able to coordinate that across multiple sites, and I think they've just upgraded that fairly inexpensive, actually. You can use that as a supervisory level and go down and do an audit. If you want information on that audit information, go to inspectionpad.com, sign up, get the iPad app, and download it. We have no issue with you using those questions, even if you don't use that Inspection Pad app, but it actually makes it quite convenient to be able to track that across multiple facilities and be able to pile up that data and do some data mining to see if you're getting similar problems across an area. Maybe you need some more training, or maybe you need to provide some better PPE. You can dig into those things that keep popping up that are violations in your own organization. Helps you be a little more proactive rather than reactive, waiting for somebody to get hurt.
Very good. And that's a good place to probably wrap up our presentation.